Bird wing again, there's the arm, and there's that wrist and the hand, and those are the flight feathers off it. Now they're zooming up here. The hand wing gives us the thrust. And so, going back to that semilunate carpal, that modified bone in the wrist, this part of the bird hand can make this circular motion. So, lift and thrust. I think I said that a bunch of times already. Here's where the asymmetrical feathers come in. Remember I said the feathers are asymmetrical? Here they are. They overlap with the thin end of one feather overlapping the thick side of another feather. Like that. Can you picture like Venetian blinds?
Oh, yeah.
So, if adjacent feathers are like this, they can open up like a Venetian blind or they can close, right? But they can't close both ways. So, on the downstroke, when those feathers are pushing down, it's like the Venetian blind, they're up against each other, the slot can't open. So we get a solid surface on the downstroke. Because, I forgot to say, is the feathers twist in their sockets. So these feather shafts are twisting, and they're twisting against each other. And so on the downstroke, they can't twist against each other, and we get a solid surface. So when you're pushing down, you're pushing the air down. Then, when the upstroke occurs and feathers pull up, those feathers twist in the sockets, and they open up. So, we're pushing down, we get a solid surface. We're lifting back up, the air slides between the feathers. Down, solid. Up, air flows through. And that's why people would watch birds flap their wings and make, wings out of leather, and they run around doing this, and you get no lift, because think about that. You're pushing your hand down, and there you get lift, great, but when you pull your hand back up, it just cancels it all out. But as birds push down, it's closed. As they pull back up, it's open. And so, doing this motion up and down and circular with that wrist, the hand is giving us thrust. And as we move through the air, the arm wing is giving us lift. And that's the key of asymmetrical feathers. It's this twisting motion. They close on the downstroke, they open on the upstroke. Yeah?
Is that reducing drag?
Drag, yeah, you can think of it that way, but drag's another issue. Yeah, it's reducing the drag as you go back up. Yeah. Closed on down, open on the up. That semilunate carpal again allows this really efficient wrist movement. Move that, and that's where most of the thrust comes from. So, enemies of thrust, enemies of lift, are drag and turbulence. Drag is anything that interferes with the air flowing over your body. And you know this, if you're driving in your car and you put your hand flat out, that's going to be some drag, right? Open your fingers up and it's less drag. Close them up, a lot of drag. So birds are a lot about drag reduction. Airplane design, submarine design, same thing. Fish design, same thing, drag reduction. You want a nice smooth body so the air flows over you very cleanly. Friction drag is the drag as the air encounters the body. And if we make a nice smooth body, we lessen that friction, we lessen the drag. And you have to invest less energy to get the thrust you get the thrust. And the problem with birds is they're reptiles. And it's not exactly an aerodynamic shape there. But we want to push that through the air, like pushing a crocodile through the air. And that's where the contour feathers come in. They smooth out that otherwise very rough body and structure the flow of the air over it in a very efficient way. So contour feathers function in that. Another type of drag is turbulence, and this is the same thing moving fish through the water, which is turbulence. And at the end of a body part, like the end of a wing or the end of a tail, as those masses of air come back together, there's going to be turbulence, whirlpools in the air. And that's going to cause drag. It's going to slow the movement of the animal through the air. It's going to sacrifice lift. So anything you can do to minimize this would be a good thing. And birds have adaptations to do this, just like airplanes do. One is a structure called a slot. And that's a little structure on the wing, at the leading edge of the wing, and it structures the flow of the air before it hits the airfoil and avoids this, called a slot. There's an unslotted wing, there's a slotted wing. And that structure there eliminates this here on an airplane and on a bird. Here's slots on an airplane. These openings in the wing here serve that function. They're more important at slow speed than high speed. And this is a plane that did a lot of slow flying. Well, birds don't have that kind of structure, but remember this thing? The alula? There they are. The alulas act as slots, and they structure that flow. When that bird's flying, particularly at lower speeds, the airflow is structured as it goes over the wing, and it reduces this kind of stuff. Small little adaptation, big payoff. Okay. There's also vortices formed at the end of a wing, whether it's an airplane or a bird. And birds have ways to deal with that too. And they have slots at the end of their wings in some cases. These are flight feathers that are slotted. And as the air flows over that, we minimize this here. Tons of physics. If you take an aerodynamics course, you'd spend days on this, and I don't want to. But the point is, the big point is, we're moving a solid body through the air, whether it's an airplane or a bird, and there's lots of adaptations to minimize drag and maximize your thrust. And that gives us powered flight. Gives us powered flight. Have you ever watched hummingbirds? I'm sure you have. It's amazing what they can do. So wings themselves, another thing we can look at is wings, another little bit of physics. These are different kinds of aircraft, very different wing construction. These are aircraft that do different things. It's an aircraft about carrying heavy loads, not about going real fast, about carrying really heavy loads. Here's an airplane maximizing lift for energy input. In fact, there's a glider, there's almost no energy input, but it gets a lot of lift. This wing is about speed and not much else. That's not a speed wing. This wing is about maneuverability, turning and twisting. Different types of wings, different functions. And we see the same things in birds. We've got a heavy lift wing, particularly good at slow speeds. That guy's going to pick up gophers and groundhogs. There's eagles that pick up baby sheep. That's an albatross wing. Almost no energy input keeps him in the air. Very efficient design. Not going to be fast, not going to be quick and maneuverable, but that's not his niche. This is a flycatcher, chases insects down. That's a maneuvering wing. This is another type of flycatcher, a swallow, chases insects down but does it with speed. These are speed wings. And the structures here are optimized for what that bird does. That's not going to be a fast flyer. That's not either. But that's not what those wings are for. So we can link those things together. I think that's kind of interesting. Human engineers and natural selection, right? So people who do this break down to 4 different categories of wings. There's probably others out there, gray area in between, but 4 different kinds of wings. An elliptical wing is that kind of jack-of-all-trades wing, the maneuvering wing. And they're long and relatively broad. Works at slow speed, works okay at high speed. Twisting and turning works. This is a speed wing. It's long and relatively thin, and it comes to a point. These things minimize turbulence, and they're not slotted, by the way. Slotting is something at slow speeds. You don't need slotting at high speeds. This is a bird that's for high speed swimming, like a fighter jet. It's called a high aspect ratio wing. Long and narrow and pointed. This is a super high aspect wing, a soaring wing. Again, no slots. Not worried about that. Long and thin. We got a lot of lift. It's so big, we got a lot of lift at slow speed. And we have to put very little energy into it. Once we're going, we have to add very little energy to keep this kind of wing providing our lift. Then a heavy lift wing. It's heavily slotted because it works at slow speeds, really broad and relatively long. We get a lot of lift at slow speeds on this wing. Okay? Poor little guy. Well, anyway, human engineers, 120, 130 years of human engineering, 80 million years of evolution. One of the things that flying lets you do is it lets you go places. And a lot of birds make migrations, sometimes, as we talked about earlier, really broad migrations. They can, when it gets, when seasons change, it gets cold in one part of the habitat, they can go to another part of the habitat. And flying opens that option to them. We're in Southern California where it never really gets winter, so a lot of our birds are year-round, but other parts of the country, a little bit farther north, and birds disappear in the wintertime. Europeans in the Middle Ages couldn't figure out where the hell birds went. They didn't know about Africa. They just knew in wintertime all the birds went somewhere. And what they thought is the birds dove into lakes and sat on the bottom of the lake all winter. And they came out in the spring. I don't know why they came up with that idea, but there's actually nature guides telling you how to go fishing for birds in the winter, dragging the net across the bottom of a lake. Here's our gratuitous Monty Python reference for the day. If you don't know what an unladen swallow is, you should go to YouTube and find out. I mentioned earlier there's a lot of amateurs and interested lay people studying birds. And one of the ways we study birds is we band them. And a little metal or plastic band is put around their leg and has a number on it. And when a bird is netted and captured, you can put one of those bands on it, and then you record where you banded this bird, and you put that number into a registry, and someone catches that bird 3-4 years later someplace else, they can take that number, go to the registry, and see where that bird was banded. And now I'm sure it's all done on the internet. When I was helping someone do this back in the 80s, he would band birds, and he would fill them out in a journal, and then he would mail copies of that journal page to a central clearinghouse, and they would put them in a big catalog. And if you caught a banded bird, you would send them a postcard saying, "I caught bird A57-24," and they would send you a postcard back telling you where it was banded. Now it's a much more dynamic science, but that's how we learn about how birds move. And we can track these migrations. We get ourselves out of a bad part of the world into a good part of the world, or seasonally, I guess, speaking. And there's that Arctic tern migration again. Here's just northern hemisphere, southern hemisphere. Here's pole to pole. Well, not quite pole to pole, but Arctic to Antarctic. The Arctic tern is just a bird that loves tundra. Okay? Loves tundra, and that's where it wants to spend as much of its life as it can. Birds have traditional flyways. They've been using these for millions of years. These are the North American bird migration flyways. And they're very well mapped, they're very well understood, and the birds use them. They evolved to use these. And one of the things we do that makes it difficult for birds from a conservation perspective is we do things underneath them that disrupt their pattern. So we've converted most of the Great Plains to agriculture. And the birds that migrate over that, well, now they don't have 100% of that habitat for resting, for feeding anymore. And one of the very important things is that the federal government runs, many things that we run as a federal government and are very important to us, is about the current people at the Department of Interior trying to destroy the system, is a refuge system, national wildlife refuges. And one of those things is in Kansas, Oklahoma, and the Dakotas, they pay farmers to plant sorghum or wheat and then just leave it there, or leave a wetland intact. So they're like little stepping stones so they can move through there. But from a conservation perspective, it's very important to know these things. Also, the other thing you can do, if you want to open a hunting club, there's a good place for it. The birds migrate right over you. These are the worldwide flyways. Like I said, they've been very well mapped and very well understood. I don't know how they track this bird, but these are migratory pathways of the shearwater. Nowadays, this slide is too young to be like tiny electronics, but nowadays with GPS and tiny little GPS trips, we can put this kind of stuff on an animal and gather this kind of data, which we didn't have access to just 20 years ago. You guys don't realize, remember, GPS, which is in all your phones and your calculators, and pretty soon they'll chip in your brain. That was top secret military technology till 1991. First Gulf War, that was the first time anyone had ever heard of that outside the military. How do they do this? How do they figure out where they're going? They've got different ways to navigate, and some of them appear to use the position of the sun. And in their brain, it's like what's that thing that you plot the stars with in the sun, a sextant. And they figure out where the sun is coming from and where they need to go. And you can confuse them in experimental chambers by directing the sun at them from odd places. Migration has perils. And this is kind of, we can bring some conservation into our discussion here. If you're a bird that migrates to the rainforests of Brazil and you fly down there, this is Brazil, and look how much your habitat now is gone. In some cases, birds get down there and there's nothing in sight for them because it was cleared since they were last there. If this is your breeding habitat, you fly a long distance to breed on a beach, and there's all those SoCals there. That's not going to work for you. Again, we have to understand the biology if we're going to have rational conservation. They're trying to, they will get away with it, opening up the Arctic National Wildlife Refuge for oil drilling again. We've been fighting that for 20 years, not 30 years. And people with no respect for the environment, no respect for wildlife, have decided to pillage that for oil. That's going to end badly for those habitats up there. But oil companies will make lots of money, so it must be a good thing. There's that Midwest again, the Great Plains, covered with amber waves of grain. That's important. That's where we get our food. But I always think it's important to point out there was a cost to that conversion there, and the cost is loss of a lot of wildlife habitat. We can remediate that cost with refuges, but the cost was there. A lot of birds use wetlands, and you hear a lot, if you're an ESRM or you pay attention to conservation, you hear a lot of discussion of wetland conservation, because that's the places where some of these migrating animals end up. And wetlands sometimes smell bad, they make mosquitoes, so we tend to damage them, fill them up and make them into pasture land or clear cut them. And wetland conservation has been a big issue the last 30, 40 years for this and other reasons. Like I said, the pathways are very predictable, and if you have unrestricted consumption in the form of hunting, severe damage can be done to the populations. This can be managed, but if it's not, and I've been out in the field and seen duck hunters just shooting everything in sight and leaving the ones dead on the ground they didn't want to eat. When it's managed properly, it's sustainable. DDT is a pesticide that was used to kill insects, still is, and It kills the food birds eat. It gets into their systems and makes it difficult for them to lay eggs. It interferes with their reproduction. DDT is banned in most of the world, North America, but in the tropics it's still used to control mosquitoes. And you can see a bird that's perfectly safe from DDT in Canada, the United States, migrates down to Brazil and picks up a lot of it before it comes back. Again, DDT is used to control malaria. It's not a bad thing, but there is a cost incurred by using it. Here's one, just more random things here. Here's one that showed up in a issue in the 80s. This is the Mediterranean flyway. A lot of Eurasian birds, Western Eurasian birds, go down to Africa and they don't fly over the Mediterranean. They skirt and fly over the eastern border of the Mediterranean, and it's very, very predictable. And we lost a lot of birds in the 80s when there was a civil war in Lebanon. And those migrating birds flew right over Beirut. And there are all those guys down there with lots of guns and not a lot to do. They spend a lot of time shooting at birds, apparently. Okay. A couple more things here, and then we'll call down. We'll figure out what's going on in lab. I think we get a little bit farther. We'll never finish mammals. Yeah, we're in good shape. Reproductive and social behavior. Adorably proud parents. A lot of things here apply to mammals, fishes, other things too, but I'm using birds as the example for some of these reproductive issues. So, all birds have internal fertilization. Any animal that lays an egg with a shell is going to have internal fertilization. The sperm has to be introduced into the female, the egg is fertilized, and then the shelled egg is built. And that's birds doing it. Birds don't have a copulatory. Remember, lizards had those hemipenes with spikes all over. Birds, they press their cloacas up against each other, and the male shoots sperm into the female. They don't have a specific organ for that. There's the female system. It's a typical vertebrate system with ovaries and a uterus, and the eggs are produced in the uterus. One thing about birds is, again, birds are about weight reduction. Usually one side is well developed in the ovaries, and the uterus on the other side not so well developed. You only need one side to work. These are mating systems, and these can apply to anything. Insects, anything, mammals. Mating systems, monogamy, and you know what this word means. Gamy means gamete, refers to mating, and mono means one. Monogamy is when it's one male, one female. And some birds mate just for the season. It's one male, one female through the season. Some birds, each season, they seek out the mate from the previous season. They're lifetime monogamous. Apparently swans are. At least until one mate dies, they're mating with each other. Sometimes it's just through one season. Polygamy is when there are multiple mates. And that's the general term, polygamy. And look at the difference here. Polygyny is one male with multiple females. And look at the word there. Gynecologist, that's how I remember it. G-Y-N, that's a Greek word meaning female. Gynecologist. Polygyny, one male, multiple females. And then polyandry is one female, and she's mating with multiple males. Those are two different types of polygamy. I think polygamy is the word you know. Polyandry and polygyny are the two different types. And again, there are mammals that do this, there are fishes that do this. Yeah?
Do the birds also have problems with inbreeding, like dogs?
Any animal, anything that's breeding potentially has a problem with inbreeding. Yeah. So in a lot of populations, they have adaptations to pick a mate that's not their brother, so that they avoid inbreeding. That becomes a conservation issue. What if when you only have 5 whooping cranes or 5 condors, they're going to get inbred. So it becomes a conservation issue. But they do have the ability to decide what's the optimum mate for me. Not too close, not too far. Here's an example of polygyny. And got one male, and these are all his females. And the word for them, and biologists try to pick words, they're supposed to try to pick words that don't have human meaning. But what do you think we call all his females? Too general a word. That's his harem. That's kind of a human word, but it's one male, and he mates with all these females, and other males don't get to. And he gets to that spot by being big and aggressive. He has to fight for it with other males. A specific kind of breed. These are prairie chickens. You see them out in the Midwest or in the Great Plains. They're awesome. They're big birds, and during breeding season, the males fight with each other. And the dominant male in a particular area, all the females come to him, and the other males don't get anything. And it's called a lek. And what it is he stands on a specific spot and displays. And no other male can push him off that spot. He's the guy, and he gets all the females in the area. It's called his harem. That's a lek. Polyandry is less common. Polygyny, one male, multiple females, common. Polyandry, less common. That's one female and she's mating with multiple males. Here's an example. A sandpiper does that, and in her nest, these different eggs each one may have been fertilized by a different male. She mates with multiple males and then lays the eggs. In that kind of setting, she's the one who does the parental care then. The guys go off. All birds nest. I think you know that. Or you know that birds nest. I'll tell you now, all birds nest. A nest can be fairly simple. This is a puffin nest. They just push some rocks together. And there are their eggs on the side of a cliff overlooking the ocean. But it's still a nest. And there's a variety of nests. These guys are on campus right now. I love the swallows with their mud nests and their little babies peeking out. That's a hummingbird nest. It's woven with pieces of lichen and spider webs. The parents go out and collect spider webs. Not sure what that is, but wove a little nest with grass fibers between two cattail stalks. And that's a cactus wren. She builds her nest, or they build their nest inside a cholla cactus, and it's a pretty safe place to have your babies because no one wants to go in there. That's a plover nest, nesting on a beach, just a little hollow in the ground with a few rocks. Some birds burrow into riverbanks like a kingfisher, and they nest in a burrow. And an eagle nest, which is used for decades sometimes by successive generations of eagles, they pick up sticks and make a big messy stick nest, and they smell horrible. They're not very hygienic. It's full of dead, rotting animals. They bring them dead, rotting animals. It's full of poop. Some birds are incredibly clean, and even the babies know when it's time to poop, they back to the side of the nest and they poop out the side. Some birds are not clean at all, and eagles are among them. Parental care in birds is almost universal. There are very, very few birds that don't offer parental care. Again, something you probably know. And it's usually a mom and a dad. Two-parent family. Sometimes it's just a female, but usually it's a male and a female. Like these guys here. They're hideous babies. They're storks of some sort.
So with polygamy, would then that follow on one of the parents to take care of the children?
Yeah.
Generally the female?
That's like in that lek breeding, the male's guarding the territory, each female has a nest, I assume. I have to think about other examples. Here's the one bird that doesn't give any parental care. It makes a nest, but that's the end of it. It's from Australia. It's a really primitive bird called a megapode. Means Bigfoot. And they make a nest, lay the eggs in it, and I think it's the mother. She guards the nest and she cares for it, and she makes sure the temperature's right. If it's too cold, she puts more leaves on. If it's too hot, she takes leaves off. But once the little guys hatch, they just run away. And there's no parental care there. That's rare. There's almost always some parental care, and that's a very, very primitive bird. Now there's the nest there. So here she is tending it, either covering it up so it's warmer, or she'll scrape vegetation off if it's too warm. I had Dr. Chapman here for a while. She retired for health reasons a few years ago, and she knew a lot about Australian birds. And this should remind you of alligators. That's very similar to alligator biology, where the mom makes a nest, she guards the babies, she guards the eggs, and she also guards the babies. But she'll cover more vegetation on top. If it's too cold, she'll pull stuff off if it's too warm. A couple more things here. Altricial. That means helpless. I'm not sure exactly what it means, but some bird babies are helpless. They're called altricial. They need a lot of parental care. They can't do anything for themselves. They just sit in the nest and wait to be fed. That's altricial. And the opposite end of the spectrum is precocial young. These guys, when they hatch, have some degree of independence to them, or at least some ability to move around. So, think a baby chick or a duck versus one of those tiny little naked babies you might see in a songbird nest. So that's altricial, and those are precocial. They're hatched out a little bit more capable. In fact, duck babies can feed and swim like that as soon as they're hatched out. Okay. All right, let's call it a day here. I'm going to go work on lab. So we will okay, so we've got a special lab activity before our exam on Friday, so we're meeting in the lab room